welcome back to the part 2 of the structure of the eyeball. And yeah, these are going to be very short videos, but they'll have extremely intricate details. And I will be covering everything in detail, but yeah, the videos will be short. And yeah, starting off, so with the help of ophthalmoscope, whatever you see is the ocular fundus. Now, ocular fundus is the interior surface of the back of the eye, which can be viewed with an ophthalmoscope. Now, what comes in the ocular fundus? Now, for example, this red region is the ocular fundus. So it shows the retina, optic disc, macula, and fovea. Fovea is basically a depression in macula. So basically, you see retina, optic disc, and macula. Now, um, this is fundus, right? And this is the one in green, that's macula lutea. It's also known as central retina. And in blue, you see optic disc. Now, the key feature to differentiate between the two is that optic disc is situated medially, or you can remember that it's situated nasally or towards the nose. And your macula lutea, it's infrolateral to the optic disc, right? Macula lutea is also known as central retina. The other key feature is that optic disc, if you're using ophthalmoscope to examine, you'll notice that optic disc is more of a pale colored, whereas a macula lutea is yellowish in color, right? And macula lutea won't have any sort of sharp margins, but optic disc is quite defined and sharp. And yeah, macula lutea has a depression right in the center. It's slightly depressed, and that depression is known as fovea centralis. This fovea that we spoke about earlier. So fovea centralis is the depression in your macula lutea, and fovea centralis is the region of the or area of the sharpest vision. Why? We'll discuss that later. Uh, this diagram is super important. Just learn it, remember it in order to learn the positioning of your optic disc, which is situated medially, superomedial to your macula lutea, or you can say it's situated nasally, whereas the macula lutea is infrolateral to the optic disc. Infrolateral. Just don't forget this diagram. Now, these are the key differences. I've already mentioned optic disc is pale, macula lutea is yellowish, and optic disc is situated nasally. Macula lutea is central but infralateral to the optic disc. And one of the key features that can easily help you distinguish between the two, in the very case you forgot that, oh my god, which one is yellowish or which one is situated nasally, which is infralateral to the other. If you forget that piece of information, you should never forget that the optic disc is vascular. It has arteries and veins emerging from it, whereas macula lutea is avascular. It has no blood supply. So if you see arteries or veins running around, clearly you'll know that's the optic disc. And the easier way to remember is that, see, this is optic disc, right? And we know it has optic nerve passing through it. This is a better diagram, yeah. This is optic disc, and you know that it has optic nerve passing through it. But do not forget that it also has the central retinal artery. Its divisions we're going to discuss in a while. So it also has the central retinal artery, whereas macula lutea, here I've drawn macula lutea in green. It's yellowish in color. So macula lutea, it is avascular. It does not have any sort of blood supply. It depends only on choriosinusoids or choriocapillaries, which are basically the capillaries in your choroid. Therefore, this is avascular. So these are the key features that you need to remember. The optic disc is pale, this is yellowish. Optic disc is nasally situated, macula lutea is central but infralateral to the optic disc. Optic disc, it doesn't as such have a depression. It does have one that we'll discuss further. Macula lutea has a defined central depression, which is known as fovea centralis, which is the point of highest or sharpest vision, highest visual acuity. And we'll discuss that too. Highest visual acuity. We'll discuss that too. And macula lutea is a vascular, optic disc is vascular. That's the key feature, and it has central retinal artery. Now, this diagram is really good. I've drawn this, so make sure that you know everything about eyeball in this structure that's being shown. Yeah. Now you might question that. I already mentioned in my previous video that retina is a part of the central nervous system, right? That we already established. But um, how is it possible that it has a nerve running through it, that to optic nerve? When we already studied in our earlier grades that in your central nervous system you do not have nerves. If there's a bundle of nerve fibers, it's not known as nerves, it's known as tracts. In periphery, the bundle of the nerves, it's known as nerve. A bundle of fibers, they're known as nerves, right? But in central nervous system, that's not the case. Right, so here is talking about tracts and nerves. So we already know from our previous grades that if there's any bundle of white matter or axons, if it's in a central nervous system, it's known as tract. But if it's in the peripheral nervous system, it's known as a nerve. Why is it so that this is known as this bundle of white matter or axons in the central nervous system is known as optic nerve and not as an optic tract? Even though we made it clear that this entire retinal region, it's part of your central nervous system, right? So why, if this is the part of central nervous system, why is it called nerve not tract? I hope you're getting my question. Now the answer is that actually it's optic tract only. But previously the anatomists, they did not understand this, or they probably just started calling it, or they just named it optic nerve, and so everyone, so on and so forth, they started calling it optic nerve up until now. So that's basically the conventional name and the conventional way of calling it. No one dared to change it, so that's the reason it's still called optic nerve, even though actually it's optic tract. It's a tract, right? So make that clear that it's a tract. But you obviously have to call it optic nerve. I hope you guys are getting the point. So there was, like, a point that needed to be cleared, and that's not often very much discussed. So I felt like it was my responsibility to put it forth and for you all to comprehend it. And yeah, also one more thing that I have to clarify here, that the peripheral nerves, they're myelinated by Schwann cells. We all know that from our previous grades, right? And also that the central nervous system tracts, they're myelinated by oligodendrocytes. Peripheral nerves, they're myelinated by Schwann cells. Not nerves, central tracts, central nervous system tracts, they're myelinated by oligodendrocytes. So the same case is here, since this is actually a tract, so this is myelinated by oligodendrocytes, right? Even though it's called nerve, it's still a tract. It's myelinated by oligodendrocyte because it's in the central nervous system. And any of the diseases that involve peripheral nerves, it does not affect the optic nerve. It doesn't affect the optic nerve. But the diseases that involve the central nervous system tracts, for example, multiple sclerosis, it affects your optic nerve, right? Why? Because central, any disease that affects the tracts, it's going to affect this tract also. Optic nerve is a tract, it's going to affect this. For example, multiple sclerosis. I hope this very confusing thing is clear now, and if not, you can just read this. It will probably, put it forth in a better manner. And this is the diagram of the eye. Here, this is optic disc, and in optic disc, just behind optic disc, you'll see lamina cribrosa. Lamina cribrosa is a very weak point, and it's a plate with multiple holes. Through this, the bundles of optic fibers pass. So, for example, the optic fibers are originating from here. They all will pass through lamina cribrosa, and then they'll form an optic nerve. So lamina cribrosa is essentially a part of the sclera. That's why it's drawn in black. And optic disc is the region which is right in front of your lamina cribrosa. It sits right in front of the lamina cribrosa, and optic disc is also known as head of the optic nerve because optic nerve basically originates from here. And another very important thing. Now, since I already told you optic disc is vascular and your macula lutea is avascular. So you have ophthalmic artery. Its branch is central retinal artery. Now, central retinal artery, when it reaches your optic disc, it divides into further two branches. one branch is superior and the other is inferior. So this is the superior branch and this is the inferior branch. And then the superior branch further divides into two and inferior branch further divides into two. Let me recap this. We have ophthalmic artery here. It has a branch called central retinal artery. That central retinal artery, in this region you can see this is fundus. So that central retinal artery, it branches into a superior branch and an inferior branch. The superior branch divides into nasal and temporal branch. Same way, likewise, inferior branch divides into temporal and nasal. So here's the chart. So you have ophthalmic artery, then you have central retinal artery, then you have superior and inferior. Superior divides into nasal and temporal, inferior divides into nasal and temporal. And this is Macula lutea. I already told you that why is it avascular? Because it depends on the choriosinusoids. So it depends on the choriosinusoids or the choriocapillaries. That's the reason it is avascular. And Macula lutea has a depression. Now, again, another very important point that okay, before the depression part, let me just clear this thing here. That the outer part of the retina, so here the blood vessels come, right? And then they move further and they supply the inner part of the retina. Now, the inner part of the retina, it is supplied by the central retinal artery and its branches, right? Central retinal artery, superior, inferior, the nasal, and then temporal branches. These supply the inner part of the retina. How about the outer part of the retina? That is supplied by the choriocapillaries or choriosinusoids. So I already told you this is the middle layer, choroid, right? That's the middle vascular nutritive layer. So blood vessels from there supplies the outer part of the retina. I hope this video is being recorded, and also I know that I feel like the video is not up to the mark or the benchmark that I set for myself. I do have that's because I'm still learning, and this is my you know complete beginner stage where I'm still learning and figuring my way around. I have an iPad and I make remarkable notes there, and it's way easier for me to record and present there. But the issue is I am not able to figure out how to record a video with my voice in that, because I do have the screen recorder there. Obviously, iPads or Apple, it does have its own inbuilt screen recorder feature, but for some reason in my iPad it doesn't record the mic. I did take it to the Apple store and they told me that oh, right now Apple is still working on it for the mic to be functioning with the screen recorder. I don't know if that man was knowledgeable enough himself, but yeah, he did say that. So I'm really hoping that either a software comes or either an upgrade comes where I can record videos with my voice in them, because that way it will be way easier for me to record on my iPad, and I can use the laser to um, point at the words or at the diagram. That will be a lot more handy. Well, coming back to the lecture, outer part of the retina, it is supplied by choriocapillaries, and the inner part is supplied by the central retinal artery. Central retinal artery divides into superior, inferior, and then nasal and temporal. Nasal and temporal. Macula lutea, it has a depression. That depression is called fovea. Now, why? Earlier, I mentioned that it's the point of maximum visual acuity. That's where the sharpest vision forms. That's because this region has a lot of concentrated cones. It has a lot of cones. So that's the reason it provides maximum visual acuity. Now, it's not like macula lutea only has a depression. There's also a depression in optic disc, even though it's not that commonly discussed, but it's there. That's basically a physiological cup. Now, this physiological cup or cupping is basically, and let me just, sometimes in some diseases, this physiological cupping turns into a pathological cupping. That's in the cases of glaucoma, where your intraocular pressure increases a lot, it's significantly high, and what happens is that this optic disc region, it gets pushed back. When this gets pushed back, so the cup here, it's not clearly visible in the diagram that I've drawn, but it may be somewhere. Is it here somewhere? there is a cupping here, right? So what happens is that here, yeah, what happens is that in glaucoma or diseases like that, because of the increased intraocular pressure, the physiologic cup, it gets really pushed back, and this excavation deepens. When it deepens, and because even Lamina cribrosa is there, but that's point of such a weak, it's a really weak point. That's the reason it cannot really hold it, and this cup really deepens, and it turns into a pathological cupping. And because of that, it can also damage the nerves there. So this is one thing about the physiological cupping turning into a pathological one. And yeah, that's pretty much it. Just the final thing where I had to make it clear that you have retina. Like your retina has optic disc. It also has the macula lutea, which is situated. Um, a macula lutea is there, which is situated laterally, and then you have your optic disc situated nasally or medially. So the optic disc part, that is the blind spot because it has no rods and cones. Whereas your macula lutea region, the fovea centralis depression particularly, there the cones are packed. It is completely concentrated in cones, and it has, and I've already mentioned that there are 10 layers of retina, right? But in the fovea centralis region, all those 10 layers are pushed aside. Therefore, it's a really thin area, and light directly shines upon it goes directly in. So that's a region of highest visual acuity or sharpest vision forms there, and optic disc is a complete blind spot. So I really hope all of this information was clear to you all, and yep, that's pretty much it. If you guys want me to summarize it quickly in a minute, I'll do that. So in that we studied that ocular fundus is the region which you can see with the help of ophthalmoscope, and in fundus you see retina, optic disc, and macula. Macula has a depression called fovea. Optic disc also has a physiological cupping which turns pathologic in cases of glaucoma, and it also damages nerves. And then you can also see retina. Retina is the only part of central nervous system which you can see with the help of ophthalmoscope. Now optic disc is situated medially, superomedial, and your do not forget this diagram. Yeah, I know it does get confusing even for me sometimes. I end up forgetting it, but please just learn it, not just for the exams, for the sake of exams, but this information should be there with you all the time. Macula lutea situated more of laterally. Macula lutea is yellowish, and optic disc is pale in color. Optic disc is vascular. It has your central artery, central retinal artery, right, and also the veins. Macula lutea is avascular because it gets its blood supply from the choriocapillaries. And other than that, depression, central depression is there in macula lutea. And also, when you talk about the arteries, you have ophthalmic artery divides into central retinal artery, and optic disc it comes and divides into superior and inferior. Superior divides into nasal and temporal branch. Inferior also divides into nasal and temporal branch. So this flow chart is really important. It will help you remember that. Then about the tracts and nerves entire confusion, I cleared that it is actually a tract, even though it's called optic nerve. Then and it's myelinated by the help of oligodendrocytes, as happens in the central nervous system. And also any disease that affects the peripheral nervous system, it does not affect the optic nerve. But any disease that affects the central nervous system tracts, it does affect or it does involve the optic nerve. For example, MS, multiple sclerosis. And depression in macula lutea is fovea. That's a point of highest visual acuity. And there's also depression in retina, in the optic disc. That's a physiological cupping. I've already explained that. And yeah, blind spot is the optic disc part. Fovea centralis is the sharpest acuity part. So thank you so much. I was really trying to keep the video short, but yeah. So we covered this in part 2, and we covered this in part 1.